It's almost like a flag that's like, hi, I'm new, you haven't seen me around here often, and then your cells are like, oh my god, we have a foreign invader, let's attack. Welcome back to my channel, Nadine Speaks. If you're a returning subscriber, welcome back. If you have never seen this beautiful face before, don't forget to hit that subscribe button down below and click that bell to get notified of my new videos. So I'm so excited to bring you my third video in this little COVID vaccine installment. I first talked about the different phases of clinical trials, and then in my second video I talked about Operation Warp Speed. So now in the third video in this series, and I will talk about the different types of COVID vaccines that they're currently working on, and two that are already approved for emergency use. If you haven't seen those videos, I will link a playlist up here so you can go ahead and click on those and get familiarized with some terms that I'm going to be using in this video. I think it is my duty as a public health aficionado and scientist to give a little speech on vaccines and immunity and why they're so important. So if you're anti-vaccine, I'm looking at you. Yes, I'm staring at you at home if you're anti-vaccine, and I'm gonna try to do my best to educate you on the importance of vaccines and how they work, so that you're not so in the dark about how they work in your body and how our body builds immunity. So I wanted to start from the very beginning and talk about our immune system. So everybody talks about our immune system and how we can develop immunity to certain things. Well, in order to understand that first, I think it's very important to understand how we first develop immunity and what cells does our body use in order to fight those things. First of all, what happens when you get an infection? Well, when you get an infection in your body starts the immune process. The immune system process begins, if you will. So there's three main types of cells that come to our defense when we're infected with something that is foreign that our body doesn't recognize. And those are first macrophages. So macrophages are types of white blood cells. These are all types of white blood cells, by the way. White blood cells are the primary cell, and there's so many different types of white blood cells for fighting in your immune system. So the first one is a macrophage, and I like to think of a macrophage as a Pac-Man. So just imagine this like chomper of a cell just comes and eats away all the remnants of a virus, of a germ that's left behind, as well as producing antigens so that it's kind of like little flags on your body to later attack them with our antibody. And so the next kind of cell that we have are these lymphocytes called B lymphocytes, B cell lymphocytes. These B cell lymphocytes recognize those antigens that the macrophage left behind and produces antibodies to attack those leftover virus cells or leftover bacterial cells. And then last but not least, we have T cell lymphocytes, and those also attack the virus or the bacterial cells that your body has been infected with. Now, if you want to think about it this way, let's say a germ, a virus, a bacteria infects your cells, your body, it's almost as if like an alarm went off and they're like, I don't recognize this, I don't recognize this, must attack, terminate, and they start going. When your immune system is turned on, you can tell this by you feeling achy, you have a fever. Your body is trying to give your immune system so much support that, you know, you feel the effects of it, unfortunately. Actually, vaccines are a way for us to turn on that flag on a cell and let our body know that this is a foreign invader without us actually getting the disease ourselves. And it's very helpful whenever you can eradicate diseases on its own. For example, we barely see any polio now, or measles, or the plague, while there are still cases of the plague, because remember, these viruses don't go away, they're always going to be there, but what we can do to help is protect our body and give our body the best defenses to X those diseases out, so that we don't see people dying of those diseases anymore, and we're best protected and give our bodies a fighting chance to overcome a deadly disease. Vaccines help our body in different ways identify a foreign invader and eliminate it. After you get vaccinated, your body is left with the memory of what that infection was, so in order for you not to get it when you do encounter it. For example, you do encounter bacteria and so many kind of viruses every day, but your body doesn't necessarily get infected with it, or you don't see yourself getting a fever or, you know, bad side effects, because your body or immune system has already built up its defense and it already recognizes that kind of virus or germ or what have you. That being said, there's 3 different types of COVID vaccines, and these different types are just a different take or approach on how to build that defense in your body and basically give your body the instructions of what that virus is so that they can recognize it later on. So the COVID vaccines primarily focus on this protein on the outside of the COVID virus called the spike protein, and they're basically, if you can imagine the virus, and it looks like, we've all seen it with those little receptors on the outside, it uses one of those spike protein receptors to make it the prime COVID target and to show your cells like, hey, this is what it looks like, so if we ever see it, we're going to defeat it and we're going to terminate it without our body actually suffering the consequences. The 3 different types of vaccines for COVID specifically are mRNA vaccines, adenovirus or viral vector vaccines, and the third one is the protein subunit approach. So I'm gonna deep dive into all these 3 approaches and how they deliver the information necessary for your cells to produce antibodies to be like, hey, remember me? First approach, and this is the approach that we're seeing in Moderna's vaccine and Pfizer's vaccine, is the mRNA approach. So I want you to think in your mind, first of all, mRNA is called messenger RNA, and this is a kind of genetic material that your body uses in order to make proteins. So what these scientists utilize is the genetic code for COVID. They had the genetic code and they used the genetic code for the mRNA, and they almost encapsulated the mRNA into a lipid bilayer, which is just a little empty cell of fat. They injected the mRNA in there, and when they inject it into your arm, now your cells have the instructions that tell them how to make this spike protein that COVID has. When you're injected with the genetic material of COVID, and mind you, this genetic material is harmless, it's not going to cause the actual disease of COVID, but what it's going to do is provide your cells with instructions so they can go ahead and make this protein, and then once the protein is made, they now have it on their cell, where it's almost like a flag that's like, hi, I'm new, you haven't seen me around here often, and then your cells are like, oh my god, we have a foreign invader, let's attack. But this time, your cells, it does, mind you, vaccines produce an immune response, so your body saw it, attacked it, and now it's going to remember it for next time. And what's great about vaccines is your body didn't produce many side effects when they were producing their immune response to this one little harmless protein. But what it does is next time when they see that protein, they know exactly what to do and they'll react faster. See, the problem is when you have never had an infection before and your body doesn't recognize that, it will take almost weeks or days for your body to produce an immune response, because your body's trying to figure out how to respond to this thing they've never seen before. But when you have a vaccine that you've already told your body what to look out for, and now you're giving your body the best setup in order to actually come to the defenses quicker and have a better defense moving forward. The second approach I want to talk about is an adenovirus viral vector approach. Now this is really cool because this is the ones that you heard that they have a live virus. So what they do is they take the cold virus, which is called adenovirus. Through the cold virus, they inject the genetic material of COVID, also genetic material that is harmless of COVID, into the virus's DNA. Then, just like the mRNA, they inject it into your cells. Your cells now have the proper instructions to make these spike protein, and voila, you made the protein, your body sees it, defends you, and now, boom, the next time they see it, they're gonna be ready on the defense again. The third type of vaccine that they're using is the protein subunit. So instead of using the genetic material per se, they already use the spike protein that's already made. So what they're doing essentially is inserting protein, the spike protein, already in your cells. Your cells don't have to do much but express the protein, and then your B cells and T cells attack it and recognize it and produce antibodies for next time, and voila, you have proper defenses against COVID if you ever encounter it in the future. If you want to think about it on a grander scale, is these vaccines use a part of COVID that is harmless. It won't make you get COVID actually, but it uses this little piece of COVID and makes your cells express the piece of COVID in order to show your immune system, hey, recognize this, see this, if you see it in the future, attack, and that's it. And there's 3 different ways that they deliver this message to your cells, and those are the 3 different types of vaccines. It's pretty simple. And the other thing I wanted to include in this video is herd immunity. So I'm sure you've heard of herd immunity in the news about people who cannot get vaccinated. They keep saying, oh, this percent of the population needs to be immunized in order for there to be herd immunity. So it's actually 50 to 90% of the whole global population needs to be immunized in order for us to see herd immunity. Herd immunity is protecting those that cannot get the vaccine themselves and cannot produce the antibodies themselves. So we need to protect those who can't necessarily get vaccinated right now. And right now we have not had any pediatric studies or studies on children to see how well the vaccine, if it's safe or effective. So as an adult population, we need to get vaccinated for the children and for people who are immunocompromised. So people who don't have such a good immune system, we need to, as a population, get immunized or vaccinated for them. I'm curious if you are pro-vaccine or anti-vax, what your thoughts are on the different COVID vaccines and what you think of the 3 different approaches I described in this video. What problems do you see with the vaccine, or do you have any concerns about the vaccine and how it's being spread? I talked about in my first video about global access for the vaccine and them actually allocating the vaccines to people that are poor and are in underserved populations. This is really important as we see the vaccine roll out and who gets the vaccine. I hope you liked this video and how I broke down all the different types of vaccines out there and how our immune system uses vaccines in order to build a good defense system against our foreign invaders. Leave a comment down below if you liked what you see. Give me a big like if you're liking this series so far. I plan to make more videos just breaking down the science for you in common sense terms. Thank you so much for watching, and I'll see you in my next video. Bye guys!